Hello everyone, welcome to After NIPER mission. Today we will discuss the organic reaction, the most important part of organic chemistry, that is organic reaction. Okay, so let's start. The organic reactions means they happen when two molecules close together. Okay, to happen the reaction, the molecule must close together, and the reaction happen between two molecules, that is the A and B. Suppose we take the example of this reaction. Suppose we take an A or B, and there is a formation of new molecule, that is a AB, and the formation of new bond. Okay, to understand the organic chemistry, we need to understand the two basic language of this subject. First one is the language of structure. Language of structure means what? The structure, the language of how the structure of atom, the structure of bond, and the structure of orbitals. Okay, and this is the first language. And the second language is to understand the organic chemistry, the language of reactivity of molecule. Okay, to happen the reaction, the molecule should react. Okay, in general what happen, the molecules, they are not close together. Okay, but we have to overcome the energy barrier, minimum activation energy barrier, to happen the reaction. Okay, so we will see here how the reactions is happen. Okay, to happen the reaction, we want the two species. First one is a electrophile and second one is a nucleophile. Okay, these two species is very important to happen the reaction. So we will see what are the electrophiles and what is the nucleophile. Okay, see, this is an electrophile, then second one is a nucleophile. Okay, then the formation of product, this is a product is formed. Okay, it is a E nucleophile. Okay, this is the final product. How there is a movement of electrons from the nucleophile to electrophile. Why the movement of electrons from electrophiles, why this happens? Because the nucleophiles always donate electrons and electrophiles always accept electrons. Means the nature of nucleophile is always electron rich species. Okay, electron rich species, and electrophile is an electron deficient species. Okay, electron deficient species. Nucleophile is always donate the electrons. He is very rich and he has a capacity to donate the electrons. That's why the electrophile accept the electron, and there is a formation of electrophile nucleophile bond, that is the new molecule. Okay, and this is what is this? This is the curly arrow. Okay, this is the curly arrow to donate the movement of electrons, and this is the arrow we call it a reaction arrow. This is a straight arrow, this is an arrow of reaction. Okay, this is the electrophile nucleophile reaction. Okay, in basic, what is nucleophile? Is an electrophile, means nucleophile. Keep note that the nucleophile is always donate electrons and electrophile always accept electrons. Okay, next, what are the how to identify this nucleophile and electrophile? We must know the how to identification of nucleophile and electrophile. And see, these are the example of nucleophile. These are the example of nucleophile. This is the ammonia. It donate the lone pair of electrons. It has a lone pair of electrons, such as ammonia. Then these are the amines. This is water, and this is the alcohols. They have a capacity to donate electrons. They always donate electrons. That's why we call it as an nucleophile. Okay, and electrophiles. The electrophiles always accept electrons. To understand the basic how the reaction is happen, we will discuss one very basic reaction. Okay, see, the reactions of ammonia. See, this is the reaction of ammonia, lone pair of electron, that is, and the reaction with boron. Okay, boron having a empty orbital. Okay, empty p orbital, and the overlap of these two orbital, that is this nitrogen fully filled low orbitals, and this empty p orbital, this overlap happen, and the formation of new bond, and such a overlapping leads to the formation of new product. Okay, such types of reactions happen in organic chemistry. Okay, this is very simple to understand organic chemistry. Okay, to understand how to identify the nucleophile. Okay, see, this is the simple chemical reactions, and second one is the H plus we know the Cl minus C. The lone pair of electrons, this is negative and this is positive. Negative, we know that nucleophile always in negative and electrophile always in positive. Okay, so movement of electrons from negative species to positive species leads to a formation of product, that is a HCl. Such reactions happen. Okay, now to identify the nucleophile, how nucleophile donate electrons, which species donate electrons, and we call it as a nucleophile. See, this ammonia, it is having a lone pair of electrons, okay, and this is the, we call it as a nucleophile. Second one is the molecule which are having a negative charge, that is the Br minus. He can also donate electrons. We call it as a nucleophile. And second is a double bond. Why we call it a nucleophile? Because see, the CH2 double bond, CH2 has an pi bond, and you know that there is a sigma bond and this is a pi bond. Pi bond having a horizontal overlap. Okay, this is, and it can be easily breakable. Okay, that's why the alkene olefins can act as a nucleophile. Okay, they donate the electron. Now moving to electrophiles. Okay, these electrophiles having a capacity to accept electrons from the nucleophile. Okay, see this H plus, it is an electron deficient and a positive charge empty orbital. It is an empty orbital. That's why this accept the lone pair of electrons. Okay, then this is the, you see, this is the neutral molecule with empty orbital. You see, it's a BF3. Okay, this is the BF3. Empty orbital is there, and it accept the electrons from the electron rich species, from NS3 or any other species. Okay, and the second one is the molecule having a double bond. See, there is a molecule having a double bond and having the electron negative element. This is the negative element, oxygen. Oxygen is electron negative. See, the electrophiles, the nucleophiles, this attack on this carbon. This is a very electron deficient because of this oxygen. Why this more electron deficient? Because oxygen is electron negative atom, and it accepts, pull the nucleophile, the electronic charge toward itself. That's why this carbon become more electron deficient. That's why the reaction happen is very easily. The nucleophile easily attack on this electron deficient species, and this the for reaction is happen. Second one is the when there is a single bond. Single bond having electron. See, this is a Cl minus. Cl is always electron negative. Its halogen C is always electron negative, such as chlorine, bromine, iodine. Okay, and see, and this is a single bond having electron element. This is the electrophiles. These are the example of the nucleophiles, and these are the example. And the second one is a electrophile. Okay, this is the very basic to understand the organic chemistry. For you must clear about the electrophile, what is electrophile and what is nucleophile. We will see in the next lecture the various rearrangement, the name reactions. Okay, so thank you for watching.